Hello class. Hopefully I didn't chop my head off this time, but it doesn't really matter because you're here for the math, not for my face. Okay, today is lesson 11, part 2. We are solving quadratic equations by using the square root. Excuse me. Method. Just drank a monster. All right, so part 2. This is actually kind of quite simple. We're going to build off of things that you already know, like solving an equation. So first of all, if I have 6x plus 10 equals 40, and I was asking you to solve for x, okay? The x is what you're trying to get by itself. You're trying to isolate it. So this is the term that the x is in. So you get rid of the term that has nothing to do with it first. So since you're adding 10 here, if you want to move it to the other side, you have to do the opposite operation. So that would be subtracting 10 from both sides. Also, don't mind the pounding. My dog is right outside the door trying to, a little bit of separation anxiety, but okay, don't mind that. All right, subtract 10 from both sides. 40 minus 10 is 30. And so then you're left with 6x equals 30. 6 times x, so to undo that, you would divide by 6 on both sides, and therefore x equals 5. Okay, if you can do that, you should be able to do what we are learning today. So the first part there, solving quadratic equations using the square root method. This is very, very important. You are going to isolate the part that's squared. So just like over here, we were isolating to get x by itself, we're going to isolate the part that's squared. Because not necessarily will it always just be an x that's being squared. So the only thing that's being squared in this first example is the x, but over here, this whole quantity of x minus 1 is being squared. So in words, I'm going to say isolate the part being squared. So in those blanks, isolate, all cap, highlighter, circle it. It's important. Isolate the part that's squared. All right. So, I'm going to do most of the examples with you. You only have to do one of them today, so you got lucky there. All right. Example 13, 4x squared plus 7 equals 23. So, here, first thing you should do is locate the part that's squared. So just the x is being squared. So that means it's in this first term here, which means that I would want to get rid of this term over here because it has nothing to do with the x. Remember, we're just trying to solve for x. It's an equation. So we would do the reverse. So first, if we subtract 7 from both sides, 4x squared is what's left on the left side. The 7's cancel here, and then 23 minus 7 is 16. Okay, so now 4x squared equals 16. Remember, x is being squared, so we want to get it by itself. Right now it's 4 times that, so we need to undo that. And how do we undo multiplication? Division. So divide both sides by 4. The 4's cancel here, and we're just left with x squared equals 16 divided by 4 is 4. All right, so we successfully got the part that's squared by itself. It's isolated. Now, we're trying to solve for x, not x squared. So, if you have x being squared, you need to undo that. And what operation reverses squaring something? Well, if you remember from lesson 10, square roots. Okay, so square roots are the reverse of squaring something. Excuse me. Sorry, there's always something. Not to mention, this is the second time I've filmed this lesson. First time, got 8 minutes. Stopped. I don't know why. Okay. Probably why I drank a monster. Next, x is being squared, so to undo that, you need to square root both sides. Because whatever you do to one side, you have to do to the other. And so square rooting something that's squared, those two cancel each other out, and you're just left with the x. X equals the square root of 4. What is the square root of 4? 2. But what we need to know about this is a special case. So when you're square rooting a number in an equation, you're asking yourself what times itself gives you 4, right? If you're square rooting 4, what times itself gave you 4? Well, we know that 2 times 2 times itself is 4. But also that x could have been a -2, because a -2 times a -2 is also a +4. So not only is our answer +2, but it's also -2, and we denote that with a plus and minus sign. So that's plus or minus, showing that our answer is a +2 and a -2. So we have 2 answers for this equation, which should make sense because it's quadratic. And if you remember, a quadratic is a parabola, a U shape. This one is opening up, okay? So it's crossing the x-axis at -2 and +2. Those are the 2 roots of the function. That's what we're finding here. That's the big picture. We're trying to solve for x, those roots of the function. Okay, fun fact there, the reason we have 2 answers is because of the fundamental theorem of algebra. And what that states is that your degree, remember that's just the highest exponent, is equal to the number of roots of your function. So since our degree was 2, that means we have 2 answers. If my degree, say it was 3x to the 10th plus 6 equals 70, I don't know, the degree of this function is 10. So there would be 10 answers for this, 10 roots. That's just a fun fact. You don't need to know that. Fundamental theorem of algebra, but it is good to know. All right, example 14. 5 times the quantity x minus 1 squared equals 50. So this is what I was talking about, where it's the part being squared. So this whole thing is being squared, so we want to isolate this whole thing. So it's 5 times this whole thing. So to undo that, we would need to divide both sides by 5. He's fine, I swear. Okay, so then on the left side, you're left with the quantity x minus 1 squared equals 50 divided by 5 is 10. So now we have the thing that's squared by itself. So just like the last example we did, now we need to square root it. We're not going to do anything with that x plus 1. It's on the inside. That whole thing is being squared, so we need to undo that whole thing. So square root the whole thing. And whatever you do to one side, you have to do to the other. But since you're taking the square root of a number within an equation, don't forget your plus or minus. So, a lot going on here. On the left side, the square root and the square cancel each other out. You're left with x minus 1. On the right side, it's equal to plus or minus the square root of 10. Okay? Before, we had a perfect square. So the square root of 4 was just 2. Okay, that was a perfect square. But the square root of 10, that is not a perfect square. Okay, it's not on our list. But you should absolutely check to see if you can simplify that radical. And I would recommend simplifying your radical before you get the variable by itself. So we square rooted both sides, simplify the radical. Does the square root of 10 have a perfect square factor? Any of these numbers in the list, can you divide out of 10? No. So this radical just happens to be simplified. Don't worry, we'll get to an example where it's not. So that part is done, and so now we can get x by itself. Right now it's x minus 1. So to get x by itself, we need to add 1 to both sides. Watch carefully. So x equals, this is a regular old number. This is a rational number, but plus or minus the square root of 10, that is irrational. It's a radical, so they don't just combine. You don't get plus or minus the square root of 11, okay? Remember the square root of 10, if I were to type that in a calculator, is 3.1622, blah, 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 because it's irrational. It goes on forever. So it's not just 11. So the way that we write this is 1 and then plus or minus the square root of 10, okay? Your plus or minus is always going to stay in front of your radical, and then you're just adding 1 to it. So this is technically your answer. But again, according to that fundamental theorem of algebra, you should have two answers. Well, they're both there. The plus or minus is what gives you both answers. You could type that into a calculator. 1 plus the square root of 10. I did that earlier the first time I taught the lesson. So in my calculator, it's 4.1622, and then it keeps going. And 1 minus the square root of 10. Okay, again, it's already in my calculator. It's negative 2.1622, blah, blah, blah. So those are your two answers. You can leave it in radical form, which I would recommend that you get comfortable with because this will help you in Algebra 2 and later on. Or decimal form, okay? Either one is okay. Again, this parabola is opening up because the a value is positive. And so these values are just where it's crossing through the x-axis. Here at negative 2.16, blah, blah, blah. And here at positive 4.1622. That's just where the parabola is crossing through. They're the roots, okay? All right. Moving on, example 15. So we have x squared divided by 6 minus 2 equals 0. Here is the part that's squared. It's in this first term here. So let's get rid of the term that has nothing to do with it. So if we add 2 to both sides, we get x squared divided by 6 equals 2. So now x squared is being divided by 6. So to undo that, multiply both sides by 6. The 6's cancel here, and you're left with x squared equals 12. And now you have your part that's squared isolated. So you can take the square root of both sides to undo that. So square rooting both sides, not forgetting your plus or minus. So on the left, we're just left with x, but on the right, we have plus or minus the square root of 12. Do you think we're done? Of course not. Because the square root of 12, does 12 have a perfect square factor? Yes, it does. So that means that we can simplify this radical like we did in lesson 10. So the square root of 12, again, your plus or minus is going to stay in the front. We're just rewriting this differently, okay? So x equals, the biggest perfect square factor of 12 was 4. So that becomes the square root of 4 times the square root of 3. We're using that product property to split this apart into two different products. Okay, so the reason we like that perfect square factor is because the square root of 4 is just 2. So x equals plus or minus, still in the front, 2 times the square root of 3. You can put the little multiplication dot there, but you don't have to. They can just be touching. So x equals plus or minus 2 times the square root of 3. That would be your final answer. Again, it looks a little funny because we're not used to seeing numbers with radicals in them. This is just an irrational number. You could type it into a calculator. It would be a decimal that goes on forever. The two answers, one is the positive version, 2 radical 3. The other is the negative version of 2 radical 3. Okay? So there are your two answers. Good? Good? Okay. Example 16. The quantity of 2x minus 5 squared equals 81. The part that's squared is already by itself. So we can just begin by square rooting both sides. So the square root undoes the squared part, and we're left with the quantity 2x minus 5, which at this point we don't really need the parentheses there anymore, equals plus or minus, don't forget your plus or minus, the square root of 81. What's special about 81? It's a perfect square. So 2x minus 5 equals plus or minus, and then the square root of 81 is 9. All right, so what you should notice about this one, we no longer have a radical. That's good, because now our answer is rational instead of irrational. But kind of a twist on how to solve this. You don't add 5 to a plus or minus 9. Okay, remember that's two different numbers. So what I would highly recommend doing right now is splitting this up into your two different equations. The first one being 2x minus 5 equals that positive 9. And then your 2x minus 5 equal to that negative 9. So there's your plus or minus 9 from that radical. Okay, and then just solve your two equations separately. So the first one, we're going to add 5 to both sides. So 9 plus 5 is 14. And then divide by 2 on both sides. And 14 divided by 2 is 7. So there's your first answer for your quadratic equation. And then your second one, solve for x, add 5 to both sides. So a negative 9 plus 5 is negative 4. So you have 2x equals negative 4. And then divide both sides by 2. And so x equals negative 2. And so therefore, these are your two answers for your quadratic function, 7 and negative 2. Okay? So that's an example where you're taking the square root of a perfect square, which, hint, hint, you might encounter again in example 17, the one that you need to do on your own. There's a lot more going on in this one, so that's why I'm going to do example 18 with you, but 18 and 17 are kind of similar. And you also, again, might encounter a perfect square. All right, so you are doing 17 on your own. 18, we've got 1/3 times the quantity x plus 4 squared plus 5 equals 30. So there's a lot going on here. But again, we're trying to get the part that's squared isolated. So the thing that's squared is the x plus 4. That whole quantity is being squared. Then it's being multiplied by 1/3, and then you're adding 5 to get 30. So working backwards, this whole first term has a squared part in it, so get rid of the one that has nothing to do with it. Move to the other side. So if you subtract 5 from both sides, 30 minus 5 is 25. So we have 1/3 times the quantity x plus 4 squared. We're subtracting 5 from both sides to get 25. Okay. Next, it's 1/3 times this whole quantity squared. So to undo that, we could divide by 1/3. But remember, dividing by a fraction is the same as multiplying by the reciprocal. So if we were to multiply by the reciprocal of 1/3 is 3/1, or just 3. So if we multiply by 3 on both sides, the 3 and 1/3 cancel here. So we're left with the quantity x plus 4 squared equals, and then 25 times 3, think of quarters, right? If you have 3 quarters, you have 75 cents. Okay, and now the part that's squared is by itself. Yay! So now we can move on by square rooting both sides. On the left, the square root and the square cancel each other out, so we're left with x plus 4. On the right, don't forget your plus or minus. So we have plus or minus the square root of 75. Okay, so here's where it's going to get fun. Remember, I recommended looking at your radical part first before you get the x by itself at this point. The square root of 75, can you simplify that? Does 75 have a perfect square factor? Well, if you even look back, yes, okay? Again, think of those quarters. So this radical can be simplified. So we're going to simplify that first. Again, the plus or minus is going to stay in front of the radical because we're just rewriting what this looks like. We're not changing its value. We're just rewriting it by simplifying it. So x plus 4, I'm just going to leave that be for now. He's back. The square root of 75, the biggest perfect square factor was 25. So we've got the square root of 25 times the square root of 3. That simplifies to just 5. So I'm going to rewrite this again. X plus 4 is just chilling. Plus or minus 5 times the square root of 3. Okay, so what we've just done there is we've simplified the square root of 75 into 5 radical 3. Again, the plus or minus is in front of all of that. Now we can get x by itself. So x plus 4. To get x by itself, we'd have to subtract 4 from both sides. When you do that, remember this was all a part of the radical. 5 times the square root of 3. Okay, that's some crazy decimal. We don't just subtract 4 from that number, okay, because this is a radical number, this is not. So keep them separate. So by subtracting 4 from both sides, what our final answer is going to look like is negative 4 plus or minus 5 radical 3. Okay, so you're just basically tucking that negative 4 on the other side of the equal sign. And that is your final answer. The plus or minus, again, gives you 2 answers. Let's type that into a calculator, just so that you can see what those values look like. So we've got negative 4 plus 5 radical 3. So negative 4 plus 5 radical 3 gives you 4.66025, goes on forever. And then negative 4 minus 5 radical 3, negative 4 minus 5 radical 3 is negative 12.66, blah, blah, blah. So you do get just 2 numbers, 2 irrational numbers that go on forever. Those are the roots. That's where the parabola is crossing through the x-axis, and that was the whole goal of solving these quadratic equations. Okay, so you are to do number 17 on your own. That was solving quadratic equations by the square root method. And when we come back, we'll do the next. I hope that you have a great day and enjoy the sunshine out there. Bye, guys.